Yes, hi guys. Now question number 10 we are doing. Okay, so ninth question we did. In the same way, this 10th question is also having a similar kind of question. Here it is sin q, here it was cos q, and e2x here it is ea or ax. In place of 2, we are a the constant value. Right? So it will be in terms of constant. Sorry. So question number 10 we are doing. Now, the 9th question will be completed, and after that, we take the 10th question. Question number 10, how it is to be get a reduction formula, or finally it is to be integration. To integrate it with by parts, integrating it by parts, considering sin, again Euler formula, it means a exponential function is the second function, trigonometric function is the first function. Considering sin qx as first function, and e raised power ax as second. The second. Let me integrate this. So, first function as it is, that means sin raised power qx as it is. Integration of eax, that we write here. Integration of eax minus sin ddx of sin qx. Integration of eax dx whole dx. This is the formula for by parts method. Okay, of by parts method, this is the formula. Now let me integrate it. So this is sin q x e raised over ax upon 8. Integration of ax is ax divided by the coefficient of x, which is a. So minus sin differentiation of qx. This is 3 sin square x into sin x, and again differentiated, it will be cos x into eax upon a dx. Let me further resolve it. It will be, let me write first eax sin qx upon a minus sin, this is 3 upon a. Now it is sin square x into cos x into eax. Okay, so sin square cos x is to be taken as first function. This I'll take eax as second function. Let me again integrate, taking sin square plus cos x as first function. Again integrating. Now let me write here. This is first equation, and integration of sin square x into cos x e raised power ax into dx. Integrating it by parts. Again integrating it by parts method. Taking sin square x into cos x as first function. Trigonometric functions are always taken as first, then exponential function. Exponential function is the last function, e exponential function. Inverse function I always discussed about this in detail when I discussed about by parts method. This is I lit L logarithm, algebraic, trigonometric, exponential. I means inverse function. This is what we have to integrate. Now let me take these two as the first function. Taking this, therefore this will be integrated as sin square x into cos x as it is. Integration of eax is eax upon a. Okay. Minus sin. Now differentiation of this will be by product sin of integration ddx of sin square x cos x. So let me first differentiate sin x, which is sin x into cos x again into cos square x. Why? Because cos x is already there. Sin x is again differentiated. Because 2 sin x plus differentiation of sin square x is 2 sin x. But sin x is not x. We have differentiated again by chain rule. Sin x is differentiated as cos x, but cos x is already there. It will be cos square x. Now plus sin. Okay, it will be plus sin here. Now sin x square x, as it is cos x is differentiated as minus sin x. It will be minus sin cube x. Right, one distinct. This will be negative sign here because cos x is differentiated as minus sin x, but sin square x is there. It is sin cube x. This is bracket. This is e.ax from a integration of e.ax. Now let me separate this. It is what? First is sin square x into cos x e.ax upon a whole minus sin. This is 1 from a that we take out. First will be 2, that we have 2 into cos square x, can also be written as, let me write first sin x into cos square x into p.ax into dx minus plus here plus sin. Okay, this is plus sign here. What it will be? It will be here plus sin cube x. The same function 1 upon a here, 1 upon a will be here sin cube x into e raised to dx into dx. So this is the same function which we started with I3. This is I3 here. Okay, this let me now substitute. So this is what integration of this we will do by substituting cos square x into 1 minus sin square x. Let me resolve it further. Is sin square x into cos x e raised power dx divided by a. This is minus 2 upon a. This is sin x. In bracket cos square x into 1 minus sin square x. 1 minus sin square x. Okay, into eax. Into eax into dx plus sin. This is nothing but 1 upon a, the same function I3. Let me take this is I3 here. This is equal to I3, but third power of sin. If I take this is equation number 1. Let me take this. Still it is not solved. Let me write it as it is. First let me solve it further. So let me write here. Let me write the first equation here. What it will be? It will be equal to sin square x into cos x into e raised power ax upon a minus sin. This is 2 upon a sin x. Sin of integration is sin x into e raised power ax into dx. Okay. First one, twice a sin x into e raised power ax into dx. Okay, then minus plus here is plus sin. Sin cube x because sin x into sin square x. Make 2 upon a sin cube x into e raised power ax. Okay, into dx. And plus 1 upon a is there. 1 upon a, same value. Let me write I3 as sin cube x. E raised power ax into dx. This is 1 upon a twice upon a. Positive value twice upon a. So this is 3 upon a. Okay, that's fine. The same function which we are integrating has been obtained at this one. Let me further write it down. It will be nothing but sin square x into cos x e raised power ax upon a minus 2 upon a sin of integration. This is sin x into e raised power ax into dx. This we will do separately. We will put that this is nothing but 3 upon a. And the same function sin 2x e raised to power ax into dx. This is our original function. Okay, this we will transpose, but before that, this is second equation. This is the second equation of this value. This has been integrated. This function sin square s cos x ax has been integrated like this. If I substitute this value in the first equation, then finally we obtain this one eax, which we are integrating. So let me write it from first and second. From first and second, substituting value of integral from second to first. From second to first, we get here. Now let me write here. Finally, we obtain from 1 ex upon sin 2x. Write it here. This is eax sin 2x upon a, first value, minus sin 3 upon a. This minus 3 upon a we have got. Then multiply this, the first equation, second equation. Let me write the nothing remaining. Sin square x cos x e raised to power ax upon a minus sin 2 upon a. Sign of integration, this is sin x e raised to power ax into dx plus 3 upon a. Sign of integration, the same function, which is sin 2x e raised to power ax into dx. Let me now write it down this. Okay, so this is the whole value. If I multiply this by minus 3 upon this, take to that side, it will come out as, let me take the last step, the left hand side. So what do we get? Finally we will get, what do we get here? This is 3 upon, let me first write so that it will be clear. Sin 2x upon a minus sin 3 upon a square is sin square x cos x e raised to power ax minus minus plus, this is 3 to the 6 upon a square sin of integration sin x e raised to power ax dx. With this minus sign, minus 3 or 9 upon a square, which is 9 upon a square, which is a minus 9 upon a square, sin of integration is sin 2x eax. Now taking this last step, transposing this to the left hand side, we will get a square plus 9 upon a square, because this will be 9 square plus upon a square plus 1 will be 1 plus 9 upon a square. Sin of integration, this is e raised to power ax sin 2x dx. This whole is going to be values eax sin 2x upon a minus sin, this is 3 upon a square sin square x cos x eax plus sin 6 upon 8 square sin of integration, which is sin x eax dx. First let me find it out. Then I'll solve sin x dx, what this value will be. Okay, so that can be then calculated and find answer will be there. Before that, let me divide by this. Therefore, sin of integration ax into sin cube x dx is equal to, this is a square plus 9, and this a square, if I multiply this by a and a square, no problem. A square will be cancelled out. So this will be obtained as a e raised to power ax sin cube x upon a square plus 9, a square plus 9 from this numerator will come in the denominator. This a square is cancelled out. This a square is cancelled out. Plus minus 3 upon this is 9 plus a square or a square plus 9. Okay, into say sine square x cos x e power x plus sine this one. This is 6 upon a square plus 9 sine of integration sine x e raised power ax into. Okay. Now this is to be further integrated. That I'll do. Before that, just understand that this is these two steps are free from sign of integration. Okay, this is minus 3 upon a square cancelled out 9 plus a square or a square plus 9, and this is the third last step. Now let me further integrate the last one. So this is third equation. This is the formula of this, but still that integral is there. This is a reduced formula. We have moved out of this. This is only I raised power I1. Why I haven't, because sin raised power 1 is there. But this can be further integrated to obtain the final answer. Let me integrate this. And sign of integration. Sin x e raised power ax is to be integrated by parts again. Integrated with by parts. Integrated with by parts. We get. Now this is first function, second function again. We always take trigonometric function first, then this exponential function at the last function from Euler formula. This is the second function. Its integration will be sin x as it is. Integration of ax upon a minus sin. Differentiation of sin x is cos x. Ax upon a. Again it is to be integrated. Why? Because cos x into ax, what it will be? It will be sin x ax upon a minus 1 upon a. We are further integrated by considering cos x as first function. It will be cos x into ax upon a minus sin. But cos x is to be differentiated. It will be minus sin x. It will be plus sin. It will be nothing but sin x ax upon a integration of ax into dx. Now this is the same function as we started. This can be taken to this side. What it will be, let me write here. This is the final state, but this value is to be substituted from here. So let me write the last value. This is the last value, this one. We have to take this last step, which is 1 upon a square, because a 1 upon a and minus 1 upon a square. It will come here, this is 1 plus 1 upon a square. Sign of integration, this is sin x e ax, this is bracket. This we are taking in this value, which is sin x ax, and this when I take minus 1 upon a square into sign of integration sin x ax to left hand side. This is common here. Alright, 1 plus 1 upon a square is the common of these two terms. This is the one time here, sin x ax. This is 1 upon a square time minus 1 upon a square. This are taken to the side. Okay, so finally we got here. This is equal to sin x ax upon a minus sin 1 upon a square cos x into ax. Second step. This we have taken already in the left hand side. So this value is to be substituted in the third one. So final answer will be, therefore sin of integration ax sin cube x into dx, which is the required value of sin. This we have to calculate is equal to the last value, this one. You write this. It will be a e raised to power ax sin cube x divided by a square plus 9 minus sin is 3 upon a square plus 9 sin square x cos x e a x plus sin. This is 6 upon a square plus 9. 6 upon a square plus 9, sorry. This is a square plus 9 in multiplication in the bracket. Value of this, which is this much. This is here. So it is sin x ex, sin x e raised to power ex upon a. Okay. With minus sin 1 upon a square. This is into cos x dx. After this, we have to plus constant of integration. Let me further write it down. What do we get? The final answer will be. Okay, let me take it with multiplication of this. What do we get here? This is the final answer. This is AES. If I take EX common, let me take 12 common. EX common throughout. And a square, yeah, a square plus 9 will also common throughout. This if I take common, this is a into sin cube x, first one, minus sin, this is 3, yeah, into sin square x cos x, second part, plus this will be plus sin a into 6 upon 6 sin x upon a. It will be 6 sin x upon a. 6 sin x upon a minus sin. This is 6 upon a square cos x. Now if I take a square also common plus the constant c. If I take a square also common, that means ax upon a square within bracket a square plus 9. If I take a square also common further, but it will be a cube. We have to divide it by this upon 1 upon a square. So this will be a cube. Sin cube x minus 3 into a square sin square x cos x plus this will be a only 6a sin x minus 6 only cos x plus constant of integration. Now this is final answer. Final answer. Question number 10 we have done. This is the final answer of question number 10. Okay. Now let us talk about question number 11. Okay, so what the 11th question say? Let me check it. Question number 11. Okay. This is question number 11, sign of integration. See Ex within bracket x cos x plus sin x into dx. Okay, now let's do it. So if I multiply this or separate it with Ex into x into cos x dx plus sin of integration dx into sin x into dx. If I integrate this first function, keeping this as it is, the equation number 1. Integrating the first part of this, here let me take, here integration of this dx into x into cos x into dx. Integrating it by parts. Integrating it by parts, we get, considering x cos x is first function and this is the second function. what it will be, this will be x into cos x as it is. Integration of dx into dx minus sin of dx of differentiation of x cos x into integration of dx into dx whole dx. This is the basic rule of bypass method. It will be x into cos x dx only. There it is dx in the power of x okay. Minus sin. Now by product rule, differentiating it by product rule, it will be cos x first x is differentiated as 1. Now minus sin, it will be x into sin x. Why is x into sin x? Because x as it is, differentiation of cos x is sin x. Okay. So x into sin x into dx, and for dx upon dx only, into dx into dx. Now let me further explain it. This is x into cos x. Yes, x into cos x, yes, minus sin. It is nothing but cos x into dx into dx. Okay, and this is minus plus here. Minus integration x sin x dx into dx. Now further, it is to be integrated. This integration, this is to be integrated. Let me first further integrating it by parts again. With x into cos x dx minus sin. Now cos x first function, it is second function. And these two as first function, second function. Integrating them by parts again. Integrating by parts again. These two are to be integrated by parts. The first cos x as it is, minus cos x as it is. Let me write in the bracket cos x as it is. Dx is dx integration minus sin. Now cos x differentiation is sin x minus sin x, which will be plus sin x into dx integration is dx into dx. Okay, this is the integration of these two. Cos x as it is, integration of dx and dx minus sin in between. But cos x differentiation is minus sin x plus sin x and dx into dx. These are the key as because it can be cancelled out by this. These two will be cancelled out. Then plus, now keeping these two same, so what it will be first function x sin x as it is. We are taking x sin x as first function into integration of dx minus sin differentiation of x sin x by product rule. It will be first x as it is, sin x is cos x, then plus sin x differentiation is 1, which is sin x and okay, so it is sin x into dx into dx into dx. This is the integration of these two. Let me further write it down. With x into cos x dx minus sin. If I separate them, with cos x into dx cos x minus sin, it will be sin of x dx into dx. Let me check it. Okay, this one minus sin here, minus we are multiplied minus sin x dx plus sin this x sin x dx. Now this if I separate, be minus sin. Okay, this minus sin there. Minus sin x cos x, which is the original value, into dx minus sin second step, it will be sin x into dx and dx. What do we see here? Sin x dx dx, sin x dx dx. These are two same functions, and this is the original value. This original value can be taken to left hand side here. You are integrating x cos x. If I take this x cos x dx, which is said to be twice of x, transposing this function is to left hand side, we will get, let me write it here, it will be twice of x cos x into dx is equal to this value, which is x cos x dx minus cos x into over x. Now this value and these two values, they are different values, but x sin x. Okay, this is minus sign, or this is minus sign. Okay, in between we keep minus sign, right? In between we keep minus sign. So a.Sin to cos x sin x integrate, differentiated as sin cos x sin x is cos x between minus sign. Okay, no problem. This is also minus sign. 1 comes twice, between minus 2 times. 2 times between minus sign. 2 times sin of integration sin x into dx, both this one and this, they are same, they are added up with this minus 2 times plus this value 1 plus x sin x e raised to x dividing by 2. Finally we get here this value, this dx sin x, let me write it. Finally dx sin x, because dx x cos x, dx x cos x dividing by 2, we will get here 1.2 x cos x dx. If I take dx completely, first after this, whatever it is, this is minus 1.2 cos x into dx. This 2 to cancel out, it will be minus sign of integration, this is nothing but sin x into dx into dx. Last step will be 1.2 x sin x into dx. This last step. Okay, so this is